All right, here we go. So section 2.2, we're going to start talking about what are called permutations, which we'll get to in just a minute. We're going to do a little introduction here. So we've got 5 people on committee. They're planning an event. It says we have 1 member for publicity. Another will reserve a room for the program. So if I want to find a number of different ways we can assign pairs of members to these 2 tasks, since 2 assignments are different if either the task is handled by different people, in particular, if they switch tasks, it's a new assignment. So long story short, order matters. Okay, so if it's like Ashlyn and Ben, so Ashlyn on publicity, Ben on reserving a room, that's different if they flip-flop, and that would be a different assignment. Okay, so if we want to figure this out, we've kind of done something like this before. All right, if this is for publicity, this is for reserving a room, you have to look, all right, well, how many people do I have to choose from for publicity? So I have 5 people. So let's just say Emily is who we select. So that means she can't be on reserve a room now, so that means she's out. So I have 4 left. 5 times 4, 20 wins. Okay? It's kind of a lot like what we're going to be doing in this section. All right, so permutations, which are basically counting arrangements, how many ways we can arrange things, okay? So, formal definition of permutation is an ordered list of elements selected from a set. 2 permutations are different unless they consist of exactly the same elements in exactly the same order. Okay, we say elements in a permutation are distinct, and then they're choosing without replacement. All right, and order matters. In other words, if I have ABC, that's different than CBA if we're arranging them in a permutation. Okay. So if I want to list all the permutations of the set ABC, well, ABC is 1. That's one way to order them or arrange them, right? You could go A, C, B. That would be different, right? You could go B, A, C. You could go B, C, A. Go C, A, B, C, B, A. Should be it. There should be 6 of them. Okay. So those are all the permutations of that set. All right, so some formalities here. First off, some notation. Okay, this right here. I don't know if you've seen that before. N with an exclamation point. So N. Not really that exciting. Sorry, that's about as excited as I can get about what's called N factorial. Okay, so basically, this factorial means if I have 6 factorial, that means I'm multiplying basically all the integers from that number all the way down to 1. So 6 times 5, 4, 3, 2, 1. So 6 factorial would be 720. All right, that's going to play a role in permutations and also in the next section, combinations, and then some other things down the road. So this is a permutation principle. Looks kind of more complicated than it is. We're going to come back and you're going to see where that applies here in just a minute. But a formula for permutation. So if I have, so down at the bottom here, number of permutations of n objects. So if I have like 6 objects, let's just use the first example. So 5 people in that first example, take an R at a time. So taking 2 at a time. So I have 5 people, I took them 2 at a time. Okay. So the notation for that, we say the permutation, or we're going to arrange, we have n we're choosing from, and we're arranging R of them. Okay, we're choosing R to arrange. All right, how we do that, we have n factorial, so however many there are to start with. Okay, so if you think about that first example, we had 5 people, so 5 factorial over n minus R factorial, so there were 5 people, we're selecting 2 of them. Okay, So all this is 5 times 4 times 3 times 2 times 1 over, so 5 minus 2 is 3, so 3 factorial. Okay, notice what cancels. Those right there, and there's that 5 times 4 that we have. Okay. So next slide, I want to do some examples looking at this formula, and then I want you to see what you notice here. Okay, so this would be if we have 5 people. So for the first example, we have 5 people. Let's say we have 3 positions now. Okay, so 5 factorial over 5 minus 3 factorial would be 2 factorial. Let's see what cancels. Just 2 times 1. We're left with 5 times 4 times 3. The next one, we have 6 objects and we're arranging 2 of them. So 6 factorial. Right again. Over 6 minus 2 is 4, so 4 factorial. Okay, those 4s cancel with those, so it's just 6 times 5. And this last one, now we have 6 people or 6 items, we're arranging 6 of them, so numerator is 6 factorial. Denominator, 6 minus 6 is 0, is 0 factorial. 0 factorial is actually 1. Right? Does it make sense thinking about what a factorial is and thinking about why it's 1? No, it doesn't. You just need to know it equals 1. Okay? So this is just 6, 5, 4, 3, 2, 1. Okay. What's important to look at now, right? And this is the bottom. So what do you notice? Okay, so this first one, 5 times 4 times 3. This is what we started with. The second one was 6 times 5. That's what we started with. The last one was 6, 5, 4, 3, 2, 1. This is what we started with. So what's happening each time, if you notice the first number here. So the first number in each of these. So the first number in your permutation, that's always the first thing you're multiplying. And then if you notice the second number in your permutation, each time, that's how many numbers we multiplied. And it always just went from our starting number all the way down for however many numbers. So in this case, I had 5 objects, so arranging 3 of them, 5, 4, 3. This one, 6 objects, arranging 2 of them, 6 times 5, multiply 2 numbers. 6 objects, arranging 6 of them, started at 6, all the way down, 6 numbers takes you all the way down to 1. Okay? So, long story short, you don't really need the formula. So if I had permutation 10, 3, that's just 10. So we start at 10, we have 3 numbers, so 10 times 9 times 8. That is basically the permutation principle on that previous slide. So I'm going to erase this and go back. And I won't go back. There we go. So this permutation principle right here. Okay, notice what that is. So the first one was N. If we think permute N R, first one's N. There you go. R, basically we just do this R times. It's kind of hard to look at that and understand it, but that's basically what's happening. Okay. So anyway, do a couple examples here. So we got a city divided in 3 districts. They're surveyed for opinions on municipal services. There's 5 experienced survey takers available. How many ways can the surveyors be assigned to districts? were exactly one per district. So I've got 3 districts, 5 people. So I have 5, 3, meaning 5 times 4 times 3. You really don't necessarily need to think about this with the P, like the notation there. Think about it where we just have our slots for things to go. Think how many can go in the first spot. Well, there's 5 people. How many are left for the next one? How many are left for the next one? We're done. Okay, 5 to 4 next time. Okay, next example. Say we have license plates. We have the letters A, B, C, D, and E to choose from. How many are possible if repetitions are allowed? So, and we're going to assume we have to pick all 5. We have to have 5 numbers. Okay, each license plate is 5 numbers. So I have 5 numbers to choose from for the first spot. The repetitions are allowed. So each of these is just 5. Okay, so 5 to the 5th power. Okay, when repetitions are allowed, those are easier. If they're not allowed, that's where we use permutations. I have 5 for my first spot, so when I've used up one of these, I write the actual notation. It's 5 permute 5. But I had 5 for the first spot. I have 4 left, and then I have 3 left, and then 2 left, and then 1 left. And that's how we do that. Oh. So it's not really anything new yet. Until we get to this last section. Get to the next slide. Okay, so this example, we have 9 competitors. How many ways can our 3 medals be awarded, assuming they're ties? So basically, I have my gold, my silver, and my bronze. So I have 9 people that can get that one. I can't have repeats, right? I can't give all 3 to the same person, so unless they're really good. But 9 times 8 times 7, right? So nothing crazy there. These next 2 are probably the hardest things you'll see in this section. So it says how many 6-letter quote-unquote words can be formed from the word school. So when we say words, just basically we're looking at how many ways can we arrange them, not that they're actual words in the dictionary. So how many ways can I arrange school? So if, at first glance, we probably would think, well, I've got 6 letters. All right, I have 6 spots, 6-letter words. So I have 6 to choose from there. And we're assuming we can't repeat any of these. So 6 times 5 times 4 times 3 times 2 times 1. All right. So what you would think to do, which is the start, but what throws a wrench into this is repeated letters. Okay. So like if I have, let's just label I'm going to label the O's. I'm going to say that's O1 and that's O2. Okay. So is this word, this school that I have up here, is that the same word as that one? Yeah, it is, because those are the same letters, right? We didn't distinguish that O and O are different. So this is the same. So basically, with these repeats, I need to figure out how many ways can I arrange those. So it's like basically what I have is a permutation inside a permutation. All right. So what I'm doing is I'm arranging these. I need to basically divide by how many ways I can arrange that. All right. And that's going to take care of my repeat words, since these are the same thing. So doing that, my numerator is going to be what we thought it was, 6, 5, 4, 3, 2, 1. Denominator, I'm just dividing by my repeats. So I have 2 letters repeated. I have 2 times 1 ways of arranging those. I'm basically doing a permutation with the O's. Okay? I have 2 options for the first O, 1 option for the second O. Then I just do the math there. 6 times 4 times 5, all that divided by 2. Okay. The next one, the word notebook. Now we have 3 O's repeated and no other letters, so we're good there. Which I'll mention what we can do with that if that does happen. But my numerator, I have 8. It's 8-letter words. I have 8 letters to choose from. So my numerator, it's like that. Now I've got to divide by how many ways I can arrange my repeats. So I'm dividing by my repeat words, basically. So I have 3 now O's, so I can divide by 3 times 2 times 1. So again, I can arrange my O's in any of those ways, basically in 6 ways. Okay. If there was another repeat, so let's just say we spell notebook with 2 K's at the end. So let's just pretend that there was another K here. All right, then you would just multiply. We'd have to take care of those repeats. We just multiply again by 2 times 1. You just do that for however many repeated letters there are. Okay. And that's it for section 2.2. Let's see here, 2.3 is kind of the same idea, but then order doesn't matter in 2.3, so it'll be a little bit different. Anyway, that's it. Hope this made sense. Ask me questions in class.